All right, so back to our breakfast. Today you decided to have an egg. An egg is full of protein. So how are you going to digest the protein in the egg? Well, in the mouth, nothing much happens. Now we get into the stomach. And this is where a lot happens with proteins. Now you all know that your stomach is acidic. The pH of the stomach is 1 point something. So it's very, very, very acidic. The acid in the stomach is actually hydrochloric acid. All right, so there are several uses for that hydrochloric acid. Use number one, it says over here, is that it kills bacteria. So if by chance you were consuming some bacteria in that egg, you didn't cook it enough, I don't know how many of you guys eat raw eggs, but the bacteria, hopefully not too much of it, a lot of it will die in the stomach because the pH of the stomach is so low, the acid will kill it off. All right, so that's one good use of having the acid. The other main thing is that it will denature the protein. Do you guys remember denaturation from the protein chapter? We said denaturation alters the three-dimensional structure of the protein. Remember, it unravels it. It gets rid of quaternary, tertiary, and secondary structure. It still keeps the primary structure, but it completely opens it up and unravels it. And why is that a good thing for us? Well, in order for you to completely digest protein, you need to hydrolyze or break all the peptide bonds. So you want to end up with a whole bunch of amino acids. And that protein, remember how I told you it's folded and bent on itself? Well, the enzyme, no way is it going to be able to reach all the peptide bonds if that protein is completely wrapped around itself. So the denaturation, the fact that the hydrochloric acid, remember acid is one of the denaturing factors, along with heat and all the other stuff we talked about. You've unraveled it, and now an enzyme can come and hydrolyze a lot of those peptide bonds. What enzyme will do that? It's an enzyme called pepsin. But in the stomach, it first comes out as something called pepsinogen. Pepsinogen is a precursor to pepsin. So the HCl will activate the pepsinogen. What does it mean to activate the pepsinogen? It turns it into pepsin. Okay? So what happens in the stomach? The protein gets in there, hydrochloric acid is released, hydrochloric acid kills bacteria, it activates the pepsinogen, and it denatures the protein. If we wanted to talk about hormones, the hormone gastrin is released, and that's what activates all of this and sends the HCl in to do its job. But we don't need to worry about too much of the more details than what I've given you right now. Okay, in the small intestine, now you've got smaller peptides now. It's not the full protein anymore. You've got polypeptides, dipeptides, etc. They all go into the small intestine. The goal of complete protein digestion is to hydrolyze every single peptide bond. So the protein in your egg, specifically albumin, which is the main egg protein, is going to now become a pool of amino acids. Many, many, many amino acids. All right, what are the enzymes, the main enzymes in the small intestine? We've got trypsin, oh God, I didn't even spell it right. Sorry, guys. Chymotrypsin. Okay, I'm going to write it here. Chymotrypsin. Okay, so the enzymes that you need to know are trypsin, chymotrypsin, and then there's one called carboxypeptidase. There are others, but these are all enzymes that catalyze hydrolysis reactions. So they're all like hydrolases. They will catalyze that breaking of, remember the amide in the peptide bond? Break it, HOH. And now we have a pool of amino acids. And these guys, just like the monosaccharides, can now enter the bloodstream through the villi. Okay? What does your body do with all those amino acids? So let's talk about what we're going to do with the amino acids, because this has always fascinated me. What do you think your body does with the amino acids? The main thing it does with the amino acids. Like, what's the purpose of eating protein? Anybody know? Think about it. The main purpose of eating protein is to provide your body with amino acids so that your body can then build its own proteins. In fact, 75% of the amino acid pool is used to synthesize proteins. Do you guys remember in the nucleic acid chapter how I told you that the tRNA is holding on to an amino acid and it comes and deposits it when its anticodon bonds to the codon in the right spot? Well, where do you think all those tRNAs are getting their amino acids from? It's from the amino acid pool. So you ate protein to provide your body with amino acids so that your tRNAs can pick up the correct amino acids and go put them in the right order, right sequence to create the primary structure of whatever protein your body needs. Okay? Fascinating. So that is the most important thing. That's 75%. Okay, what about the rest? All right, that's number one. Number two, we can use the amino acid pool to make non-protein nitrogen-containing molecules. Okay? What do you think I'm talking about here? All right, so this is under the heading of what happens to the amino acid pools. So, amino acid pool. Number one, 75% of the amino acid pool is used to synthesize proteins. Second thing is it's used to synthesize non-protein nitrogen-containing molecules. So, synthesis. Okay, what is a non-protein nitrogen-containing molecule? What have we seen this semester? What type of molecules have we seen in biochemistry that have nitrogen in them, but we did not talk about them in the protein chapter? It wasn't in the carbohydrate chapter. It wasn't in the lipid chapter. Do you guys remember nucleic acids? Do you remember the cyclical amine bases? Adenine, guanine, cytosine, thymine, uracil. Where do they get their nitrogen? How do you synthesize them? Well, you need nitrogen. And where are you getting that nitrogen? From the amino acid pool. Pretty cool, right? So non-protein, we have to call it non-protein because they're not proteins, but they do contain nitrogen. Okay? Non-protein nitrogen containing molecule synthesis. Okay, number three. I mentioned this back when we were talking about proteins. There are amino acids that your body knows how to synthesize, and there are amino acids your body does not know how to synthesize. The ones it doesn't know how to synthesize, these are called essential amino acids. You have to consume them in your diet. The rest are called non-essential. So you need the essential amino acid to be able to synthesize the non-essential ones, and you need the nitrogen and the carbon skeleton and everything in order to do that. And these are called transaminase reactions, where you are taking an amine from one amino acid that you just consumed in your diet and putting it onto not an amino acid, just a bunch of carbons. It could be a keto acid, and then you turn that into an amino acid. So I'm going to write here, you're going to need this amino acid pool for the synthesis of non-essential amino acids. And this is basically called transamination. we won't get into the details of transamination, but